We have just heard the news that Perseverance is alive on the surface of Mars.
These images from NASA's many cameras on board tracked every tense moment of the perilous landing last Thursday.
Mars, a planet that once flowed with rivers and harbored vast lakes, now lies as a desolate world, its ancient secrets entombed beneath layers of rock and dust. However, NASA's Perseverance rover has delivered the most breathtaking visuals yet, 4K footage revealing new, unprecedented evidence hidden in plain sight all along. In this video, we confront the staggering truth that's been quietly embedded in Mars terrain. Our journey begins with the rover's, humanity's eyes on the red planet. On August 6, 2012, NASA's Curiosity rover made a daring descent into Gale Crater using the groundbreaking Sky Crane system, which utilized cables and retro rockets to gently place the rover on the Martian surface. Gale Crater, a 154-kilometer-wide basin with rich geological diversity, was chosen for its central peak, Mount Sharp, a towering, layered mountain potentially preserving billions of years of Martian history. Curiosity's main goal was to determine whether Mars had ever supported life. It carried a suite of instruments designed for complex scientific tasks. The ChemCam vaporizes rock with lasers to analyze its composition, while the MastCam provides high-resolution, color images and panoramas. The sample analysis at Mars, SAM, suite analyzes gases, isotopes, and organic compounds in rocks and atmospheric samples. Among its most significant discoveries was proof that Gale Crater once contained a lake, evidenced by clay-rich mudstone layers that form only in water. Curiosity also detected fluctuating methane levels and found organic molecules, all pointing to Mars' potential habitability in the distant past. Yet, that was only the beginning. Building on Curiosity's success, Perseverance landed in Jezero Crater on February 18, 2021. Unlike Gale, Jezero spans 49 kilometers and holds an ancient river delta and dried lakebed, rich in carbonates and clays ideal for preserving signs of microbial life. Perseverance's mission aims not only to search for evidence of ancient life, but also to collect rock and soil samples for future Earth return missions and test new technologies to support human exploration. Its scientific arsenal includes Sherlock, which detects organic molecules and minerals, PAXL, which generates chemical maps, and MastCam-Z, which captures high-zoom, high-resolution visuals. A standout innovation is the Ingenuity helicopter, the first machine to achieve powered flight on another planet. Its first flight on April 19, 2021, opened the door to aerial exploration and continues to assist in scouting terrain. Moxie, another onboard marvel, has successfully created oxygen from Mars' CO2-rich atmosphere, marking a vital step toward manned missions. Since landing, Perseverance has collected multiple rock core samples, especially from Jezero's sediment-rich delta, believed to be deposited by flowing water billions of years ago. These samples are securely stored for a potential future return to Earth, where they could offer unprecedented insight into the planet's habitability. Meanwhile, both Curiosity and Perseverance represent leaps in autonomous navigation. Perseverance's AutoNav system processes terrain in real time, allowing the rover to detect hazards and navigate more efficiently than its predecessor. Perseverance also delivers stunning 4K resolution visuals that unveil the Martian surface in exquisite detail, from sand ripples to rock textures and atmospheric haze. These images are not just aesthetic, they provide vital data to scientists searching for geological features worth further investigation. Curiosity's long mission helped refine much of this progress. Its durability through harsh Martian winters and dust storms informed the design of Perseverance's reinforced systems. Together, these rovers are transforming Mars from a distant enigma into a frontier of groundbreaking discoveries. They've bridged the gap between speculation and evidence, deepening our understanding of a planet that may once have resembled early Earth. Perseverance's descent and landing in Jezero Crater were captured from multiple camera angles, marking a historic first in visual space exploration. Despite bandwidth limitations, NASA stitched high-resolution images from Curiosity, Spirit, and Opportunity into 4K sequences, delivering crystal-clear representations of Mars' surface. In Jezero, Perseverance's exploration has unveiled ancient river delta formations, potentially containing biosignatures. Its advanced imaging tools have produced detailed panoramas of riverbeds and layered sediment, suggesting stable water sources existed over long periods. Simultaneously, Curiosity continues to gather valuable data from Gale Crater, offering a complementary perspective on Mars' geologic and environmental history. These machines, operating millions of kilometers from Earth, bring us closer to answers hidden in Mars' rocks and soil, while edging us toward the greater dream of human presence on Mars. The Martian surface presents a rich tapestry of geological marvels that tell the story of its dramatic past. In Gale Crater, Mount Sharp's layered strata act as a time capsule, preserving clues about Mars' ancient climate. Scientists have identified water-altered minerals like clays and sulfates, suggesting prolonged water activity. The gradual transition from wet to arid conditions is visible in the layers, documenting Mars' slow transformation. In contrast, Jezero Crater's river delta shows deposits of sediment carried by flowing water, with carbonates that could preserve microscopic fossils, tangible proof of long-standing surface water. Beyond these craters, Mars reveals stunning terrain, from sprawling dunes and towering craters to mysterious rock formations such as the blueberries discovered by Opportunity. Formed in water-rich environments, these tiny spherules further affirm the planet's watery past. Today, wind continues to shape the landscape, sculpting rippling patterns in fine dust that whisper of an active, evolving environment. Mars once had a thick atmosphere and a magnetic field that protected its surface and supported vast bodies of water. Over billions of years, as the magnetic field weakened, solar winds stripped away the atmosphere, exposing the planet to radiation and freezing most of its water underground or into polar ice. Findings from both Curiosity and Perseverance confirm that Mars once harbored lakes for millions of years. Gale Crater's clay-rich formations and Jezero's river delta sediments point to stable, habitable conditions. As the planet dried out, the evidence of this watery epoch remained, locked in stone. With every sample collected and every image captured, these two rovers bring us closer to solving one of the universe's greatest mysteries. Did life once exist on Mars? And with each discovery, we inch closer to the stars, fueled by the machines that never stop exploring. Mars Exploration Summary in paragraph form. Today, surface water on Mars exists only as briny trickles or sublimating frost, the faint remnants of a once thriving hydrological system. Mars' current atmosphere is composed of 95% carbon dioxide, with surface pressure less than 1% of Earth's, making it incapable of sustaining liquid water. Nevertheless, the planet's thin air holds valuable clues to its past. Isotope studies by Curiosity's SAM instrument have shown that lighter gases have preferentially escaped into space over billions of years, helping to reconstruct the timeline of atmospheric loss. One of the most intriguing phenomena is the seasonal variation in methane levels, detected by both Curiosity and orbiters. While geological processes can produce methane, its sporadic, localized spikes raise questions about potential biological activity beneath the surface. Perseverance, with its advanced sensors, continues to investigate these anomalies. Dust storms, another hallmark of Martian weather, can engulf the entire planet, reducing sunlight and temperatures. Instruments aboard both Perseverance and Curiosity have delivered real-time data on these storms, improving forecasts for future missions and revealing how Martian winds continue to shape the surface. Mars remains geologically and atmospherically dynamic despite its ancient appearance. Its landscapes, from the river deltas in Jezero Crater to the layered rocks of Mount Sharp, suggest a history deeply influenced by liquid water. Geological evidence indicates that lakes, rivers, and possibly a stable climate once existed. Detailed analysis of clay and carbonate deposits reveals that these environments may have supported life. Atmospheric data, such as methane variations and dust storm impacts, provide insights into Mars' transformation from a wetter world to its current arid state, shaping our understanding of its potential to host life and informing the search for similar processes on other planets. The question of whether Mars supported life has long intrigued scientists. Though no direct evidence has yet been found, several compelling signs continue to emerge. Fossil-like structures in ancient Martian rocks, captured by past rovers, bear a resemblance to microbial colonies, hinting at life's possible presence in Mars' wetter past. This possibility is further supported by the discovery of organic molecules, carbon-based compounds fundamental to life. Curiosity's SAM instrument identified complex organic chemicals in 3-billion-year-old mudstone, suggesting that prebiotic chemistry once occurred. Perseverance has pushed the search further using its Sherlock instrument to hunt for biosignatures, microscopic structures within rocks that might indicate ancient microbial life. These investigative techniques mirror those used to identify fossilized life on Earth. Water has been central to this search, and evidence from hydrated minerals and clays found in Gale and Jezero craters confirms the presence of liquid water for extended periods in the past. Gale Crater's layers suggest a persistent lake system, while Jazero's deltas indicate similar water-rich conditions, both potentially hospitable to microbial life. While recent Mars history has seen a sharp decline in water activity, subsurface radar mapping from orbiters has revealed significant underground water ice. Even more intriguing are pockets of briny water that might still exist, offering a potential haven for life shielded from radiation. Perseverance has revolutionized Mars exploration by not only studying rocks on site, but also collecting core samples for return to Earth. Using a precision drill, it has extracted and stored samples in titanium tubes from promising regions in Jezero crater. These samples are expected to be retrieved in a future mission jointly led by NASA and the European Space Agency, ESA, involving a complex sequence of retrieval, launch from Mars orbit, and return to Earth for advanced laboratory analysis. These efforts could yield definitive answers about ancient Martian life, deepening our understanding of planetary habitability across the universe. Technological innovations have played a crucial role in these missions. Perseverance's Mastcam-Z, a pair of zoomable color and 3D cameras, provides high-resolution visual documentation of the Martian surface, from grains of sand to sediment layers in Jezero crater. By capturing footage in 4K quality, Mastcam-Z makes Martian landscapes visually accessible to scientists and the public. Curiosity's ChemCam, which combines laser-induced breakdown spectroscopy with imaging, can vaporize rock surfaces up to 7 meters away to analyze their composition, greatly enhancing our knowledge of Martian geology without needing physical samples. These tools enable extensive geochemical and structural mapping of Mars. The Perseverance rover also employs RIMFAX, a ground-penetrating radar, to map subsurface geology and detect hidden layers or water ice deposits, all while preserving the integrity of Martian terrain. Transmitting this vast amount of data across an average distance of 225 million kilometers is a major challenge. Rovers depend on orbiting satellites like MAVEN and the Mars Reconnaissance Orbiter to relay data, overcoming limitations in power and bandwidth. On a good day, up to 500 megabytes of data can be sent, though this depends on solar energy and orbital alignment. Earth's deep space network plays a critical role in receiving this information, with signal delays of up to 20 minutes due to the immense distances involved. Looking ahead, new AI-driven imaging and decision-making tools will allow rovers to autonomously identify points of interest, reducing the need for Earth-based commands and enabling faster exploration. Future instruments will feature even more sensitive spectrometry to detect faint biosignatures. Additionally, laser-based communications are being developed to transmit gigabits of data per second, replacing slower radio systems and allowing for faster delivery of Ultra HD imagery and scientific findings. These technological leaps will not only deepen our study of Mars but also prepare us for exploring even more distant worlds. One of the most innovative breakthroughs in Martian exploration is the Ingenuity helicopter, which represents a monumental step in interplanetary flight technology. Initially designed as an experimental demo, Ingenuity became the first powered aircraft to fly on another planet. Operating in an atmosphere with only 1% of Earth's density, its success required groundbreaking engineering. The small rotorcraft stands just 0.49 meters tall and weighs only 1.8 kilograms, yet its twin, counter-rotating blades span 1.2 meters and spin at an extraordinary 2,400 RPM to generate lift in the thin Martian air. Ingenuity carries solar panels for charging, a high-resolution downward-facing camera, and onboard navigation software, allowing it to fly autonomously without real-time control from Earth. Its flight altitude ranges between 3 and 12 meters, with the ability to travel horizontally over varied terrain. Ingenuity's success has not only proven that aerial exploration is possible on Mars, but has also opened new possibilities for scouting terrain, aiding rover navigation, and expanding the scope of exploration in future missions. Ingenuity, NASA's groundbreaking Mars helicopter, has flown up to 700 meters in a single mission. Though its onboard technology is minimalist, it delivers critical data that paves the way for future aerial explorers. Its historic first flight on April 19, 2021, lasted just 39.1 seconds, during which it ascended to 3 meters before landing safely. This brief yet momentous event proved that controlled flight on Mars was viable, validating years of theoretical calculations and engineering tests. Initially launched as a technology demonstration, Ingenuity quickly evolved into a vital reconnaissance tool. To date, it has completed over 50 successful flights, covering more than 12 kilometers in total. Its missions have included scouting ahead for the Perseverance rover, mapping the Martian terrain, and identifying areas too risky for ground-based navigation. From its aerial vantage point, Ingenuity has provided scientists with unique perspectives that help target locations of interest, such as potential sampling sites in the Jezero crater's delta region. This ability to survey the Martian landscape from above has enhanced our understanding of Mars' surface and guided Perseverance's exploratory routes. The helicopter's performance has proven the transformative potential of aerial technology in planetary science, offering logistical advantages and opening new avenues for discovery. Ingenuity's success has sparked significant interest in future missions involving more advanced aerial vehicles. Scientists now envision fleets of rotorcraft exploring Mars independently, capable of traversing rugged terrain, scaling cliffs, or even probing the interiors of lava tubes. These capabilities would complement rover missions, creating a new era of integrated planetary exploration. Looking beyond Mars, Ingenuity has laid the groundwork for similar technologies to be used on other celestial bodies. One such project is the Dragonfly mission, which will send a drone to Saturn's moon Titan. There, aerial exploration will unlock entirely new opportunities to study alien environments. Ingenuity has shown that, even in the harsh conditions of Mars, engineering innovation can extend humanity's reach and its understanding across planetary frontiers. When it comes to exploring Mars, both Perseverance and Curiosity rovers have significantly advanced our understanding of the planet, each contributing in unique ways. Curiosity, which landed in Gale crater in 2012, set out to determine whether Mars could have supported microbial life. It discovered ancient lake beds, water-altered rocks, and detected methane fluctuations, clues pointing to possible biological or geological activity. Instruments like ChemCam and SAM identified organic molecules in Martian rocks, providing critical data in the search for life. Perseverance, which landed in Jezero crater in 2021, expanded this mission with a specific focus on finding biosignatures, evidence of ancient microbial life. The rover has collected several rock core samples that show signs of water-altered minerals. With specialized tools like Sherlock and PXL, Perseverance can precisely map the chemical and mineral composition of Martian rocks, crucial for analyzing signs of past life. Together, these rovers provide complementary datasets. While Curiosity confirmed that Mars was once habitable, Perseverance is actively searching for evidence of life and collecting samples for future return missions. Over a decade into its mission, Curiosity has surpassed expectations in longevity and productivity. It successfully climbed Mount Sharp, revealing geological layers that reflect the planet's climatic changes over time. This climb provided a timeline showing Mars' transition from a wetter to a drier world. Meanwhile, Perseverance has achieved remarkable milestones in just 2 years, completing the first rock core collection for future Earth return missions, deploying Ingenuity, and testing groundbreaking technologies like MOXIE, which produces oxygen from Mars' atmosphere. These accomplishments are pivotal for advancing human exploration. Both missions are products of decades of innovation and global collaboration, primarily led by NASA's Jet Propulsion Laboratory. Contributions from countries like Spain, Norway, and France have significantly enhanced the rover's capabilities. The European Space Agency's involvement in future sample return missions illustrates the shared international commitment to decoding Mars' secrets. The longevity and performance of the rovers reflect robust engineering. Curiosity, originally designed for a 2-year mission, has operated for over 11 years in the harsh Martian environment. Perseverance builds on this legacy, featuring more durable wheels and improved adaptability systems. Engineers at JPL continually update the software guiding these rovers, ensuring they remain capable in the ever-changing Martian terrain. Working in tandem, Curiosity and Perseverance represent humanity's most ambitious efforts to unravel Mars' mysteries, inching us closer to answering the age-old question: are we alone in the universe? Beyond science, the Mars missions have had a profound impact on public engagement. High-resolution images and videos from the rovers have brought an alien world to life, allowing people to experience Mars without leaving Earth. Perseverance's 4K footage offers stunning views of Jezero crater's delta and detailed images of rocks that may contain biosignatures. These visuals deepen our understanding of Mars and enhance public interest in space. Interactive tools like NASA's Mars Trek and public participation campaigns, such as naming geological features on Mars, have engaged millions globally, making the missions feel like shared human achievements. The educational impact is also profound. Programs like NASA's Perseverance Student Challenge involve students in solving real mission scenarios, and teachers use rover-collected data to teach geology, chemistry, and physics in classrooms, inspiring a new generation of scientists and engineers. Seeing feats like Ingenuity's flight or Moxie's oxygen production in action ignites imagination and demonstrates what's possible through innovation and collaboration. Mars has become a cultural icon, appearing in books, films, and art inspired by the rover's vivid depictions of the red planet. Perseverance's 4K videos have influenced visual storytelling in cinema and virtual reality. The Martian landscape, with its red sands, rugged cliffs, and alien skies, has become a metaphor for resilience, isolation, and discovery. Writers and filmmakers craft narratives around what these robotic explorers symbolize: humanity's relentless pursuit of knowledge. From documentaries to Hollywood blockbusters like The Martian, Mars has captivated global audiences, blurring the line between science and imagination. Most importantly, curiosity and perseverance are laying the groundwork for human missions to Mars. By analyzing the planet's rocks, soil, and atmosphere, these rovers help identify safe landing sites and regions with essential resources like water ice. Such data is crucial for sustaining human life, enabling the creation of drinking water, breathable oxygen, and even fuel for return journeys. Perseverance's Moxie experiment is especially groundbreaking, demonstrating the ability to produce oxygen directly from the Martian atmosphere. Terrain mapping tools like MastCam-Z support the design of habitats, rovers, and equipment suited to Mars' unique environment.